Yeah,
Or
Jonathan,
maybe.
I just now I went live. So
Oh,
if people want to come into the stream, the link is in the chat. And yes, I think this is one of the big problems of atheists. They cannot explain anything of this, you know. They
yeah.
cannot explain anything of this. They cannot explain the setup of the code of the um, establishing the code and giving meaning to the signs. Then you need the information to store the information through that code. You need the hard disk, that is the storage mechanism, and you need the transmission system that is encoding, sending, and decoding. These are four different things that have to be explained, and one has no use without the other.
And you need instruction with meaning, and for that you have to have a language.
Exactly. So that's why I'm
there's
saying you need the language, you need the information, then you need the medium upon which you use the language to store that information, and then you need the transmission system to transmit that information to where it is required. So we have actually four problems that have to be explained. And
translation, right? It has to be translated.
That is
Understood.
that is on top. You brought up an important issue. So it's actually 5 different problems that they have to explain. And in the cell, we do not have only these 5 problems. We have the genetic information, which is like a library, and then you need the orchestration, the system, which knows where to take the information and when to express it. So you have actually 6 different levels of problems and complexity that have to be explained.
Yeah, without a mind, or if not with a mind, then from where?
Well, that's why at least some honest researchers like Kunin, they have admitted openly that it is not possible to get that kind of information and information storage and transmission system by natural means, neither by chemical evolution, nor by biological evolution, nor by chance, nor by physical necessity, or whatever. And I mean,
there's a $10 million prize for anybody who can generate information from chemicals.
Yeah, that as far as I understood, it is just about the origin of the genetic code, which is actually the cipher or the translation of codons to amino acids. That is just one of the 5 problems which we have, or 6 problems which we have mentioned now.
Right.
So it is, and then you have still the information requirement to when the protein comes out of the ribosome to tag it. And there is the signal recognition particle, which is life essential. It has to be there when life started, which is the mechanism to tag the protein. And then there is, of course, another information system, which is basically a molecular GPS system. Yes, molecular alchemy. I know that my sound is terrible. It has been so. I changed my microphone today, and it's still not good. I contacted my PC technician to have a look if it is a software problem of Windows 10 or so, and I hope that I can fix it in the next couple of days. I mean, this headphone, it sounded very nice at the store, and here at my computer it's not good. So I don't think it's the problem of the microphone. It's probably a problem of the software. Do you want to come in, Molecular Alchemy? I did put the link at StreamYard at the chat. So
maybe I need to send you a computer.
Yeah, my technician, he solved another problem and he didn't have time to check this one too. So we have to wait. I have to wait until maybe tomorrow it is getting better, you know.
Yeah.
Yeah. We are waiting for you, molecular alchemy. Come in and let's have a chat and expose your ideas.
Yeah, because I was curious to know that if it's not from mind, where is it from, or where can it be from?
Well, if it's not the mind, what is it? Evolution? How does evolution? How can it be evolution if you need all the system at once in order to read, write, erase the information, and then you need the machinery? Actually, that has a purpose, and that is to drive the RNA polymerase to the right place to start um, transcription. And of course, that whole system of information processing would be meaningless if you don't have actually the machinery that subsequently will transcribe the information. So that's why I always say this is an all or nothing business. You need to have everything all at once or nothing goes. It makes no sense that you have just the code, the histone code. Why should it be there if there are no readers and writers and erasers?
Yeah, it makes no sense to say that everything that got there that has to be without mistakes, because in the cell there's, you know, many things that are working without mistakes, and all of this
Yes,
function without
yes.
mistakes. You can't
And
say that it got there by mistakes,
and as I
by making
said,
mistakes.
if you have um, the, if that information on the histone level is not um, read correctly and you express the wrong gene at the wrong moment, then the consequence is cancer or disease. So that means how do you get to that error-prone system if any intermediate or less evolved system is not functional or will provide disease?
So, is it fair to say that the maker of life is more intelligent than we are?
Yeah, I think the maker of life is unimaginably more intelligent than we are. And that is evidenced by what
I
we are
would,
just describing.
I would say so. Otherwise, we would have come up with it ourselves, or something similar, but we can't even get close to it.
We will
Not
never come
even
even close.
back.
We don't still understand so much about how cells work. What we know is that an essential part is information, and not just genetic information, but information on very different levels, and special epigenetic information and many epigenetic languages. Like the histone code is just one of 24 epigenetic languages which I have categorized, and they work together. They need to orchestrate the making, the development, and architecture of an organism in a joint venture together. So that is why about 10 years ago they came up with the requirement of looking into cells in a holistic manner. That is, they call it systems biology, where they do not just um, look into the cell specifically into one thing, but they look how things work together in a synchronized and synergistic manner altogether. And that's, of course, hugely complex. And I don't think that science um, has neither the tools to explore that kind of interaction in the cell, and neither still understands even the codification of these epigenetic languages. That their science is still at the beginning.
We can't even reverse engineer ourselves, much less make it on our own. I
Yeah,
would say that.
that's what Joel talks about. That they are trying to reverse engineer uh, biological systems, But as long as you don't actually understand the language of these systems, you cannot reverse engineer anything. I mean, cracking these codes, this is an essential part of the whole thing, you know. So science is not even there yet to crack these codes, and I don't think it will be very soon. And I mean, what I described in my recent video is that even photons, biophotons, they have some kind of regulatory mechanism, which is yet, even after 100 years since it was discovered that cells do interact and communicate through photons, science doesn't know absolutely nothing yet in regards how that codification works, how it is stored through these biophotons, and um, how it works in general. We have no clue yet. So I think we will probably never know exactly how life works. Okay, I'm waiting for you coming back. I don't like to talk by myself, so as soon as someone comes in and wants to have a chat, I will continue. I will put the video here, and until someone comes, and then I will stop it.
I was raised religion. One side of the family, long ago, Catholic, I think. The other side, Jewish.
Hello, molecular alchemy.
Hey, Tangelo, can you hear me all right?
Yes, I can hear you well.
I was monitoring the stream and I didn't want to leave you hanging. I just picked up my kids, so they're in the car with me, but we should be home in just a few minutes and I can get on unfettered.
Okay, but I hear you fine.
Good deal. I did have a chance to look at your syllogism in the last stream. I haven't evaluated it completely. I haven't gone through, every word, every statement. But you asked if I thought that syllogism begs the question.
Yes,
I think the last sentence in your first premise causes it to beg the question, because you kind of add on to the first premise that these sorts of things can only come from a mind. And I'd love to talk to you about that and get your feedback.
Yeah, I put in it here on the screen. Yeah. Yeah,
Can you read it out?
Yes, but I think I write here such systems are such a system is always devised and set up by intelligent agents. But the crux of the issue is that at the end of the syllogism, I say that since humans were not present in devising and setting up eukaryotes, since we are made of those, then it cannot have been a human intelligence. It must have been a natural, superhuman intelligent agency. But of course, maybe I can remove just that first sentence in the
That's what I was
premise.
going to suggest. Yeah, the last sentence of the first premise, and maybe see how it looks without that.
Okay.
Because
Okay, I'll do that. Let's check if that works better if I remove it, and if then the syllogism still stands.
yeah, I don't know if in the streams, I don't know if that's the best time to look. I can't look at it right now because I'm driving. I don't mind looking at it a little later with you.
Okay, no problem. We can do that when you are at home and you can join the stream from your PC.
Yeah, I'll be on Wi-Fi, so the connection will be better as well.
Yes, but basically my argument, which I asked you about right in the beginning, was how such a system could have evolved if all the components have to be there. You have there is no meaning to have a language if you don't have the meaning conveyed upon those that speak that language. And then, of course, if you want to transmit that language, you need a medium to store it, and you need a information transmission system. And you need to have all those things together. There is no sense to have readers, writers, and erasers, proteins of the histone code, if there is no message and code to be read.
So, all the cards on the table, nobody knows, and you know this, nobody knows, short of having a time machine, what exactly happened to lead to what we observe today. But we do have extant animals we can look at, organisms we can look at, and we can create conditions in a laboratory to kind of test different hypotheses. And I know this, maybe we should take a couple of steps back, because you and I are kind of continuing a conversation that started in a comment section. I know you just did a video describing what histones are, and I think that was pretty good. I wanted clarity on a few of the things you said, and I might state them a little differently, but ultimately,
as I said, molecular alchemy, I am not a professional biochemist as you are. My information is basically by reading science papers and books, and I have no problem to be corrected if I make some statements wrong or so. And I mean, what we can differ afterwards, once we have established and agreed what can be evidenced and observed on in the molecular world, how best we can explain the origin of those things. And as you correctly stated, we do not have a time machine to go back and see what actually happened. So all we can do is use abductive reasoning to the best explanation to what makes most sense.
Well, I think we have a little more than that. I do think we can make inferences to the best explanation. I know that's something you've talked about in the past. My understanding of philosophy, and I'm not a philosopher, but abductive reasoning is the conclusions resulting from abductive. You should have the lowest confidence in relative to deductive or inductive. Do you agree with that?
Yes, but I mean, if we cannot make inductive or abductive arguments, then we have to stick to the next best explanation. And I mean, you cannot generalize, for example, or using inductive arguments in regards of the origin of life. This is what Tom Jump tried to make as an argument in my debate with him. And he said, well, if we can explain the polymerization of RNA on a prebiotically, then we can extrapolate and explain basically everything, and then we can infer abiogenesis as the better explanation and hypothesis than intelligent design. And this is, of course, not true, because you have so many fields of problems which have to be explained, and they are not just by extrapolating the explanation of just one single thing. I mean, there is information, the generation of information, the generation of energy, the generation of the basic building blocks, the generation of the complexification to make the metabolic pathways, to make the interlinkage of the proteins and how they are synchronized to work together. There's so many different problems. So only someone that has really no clue about abiogenesis can make such a foolish statement. That is simply a false approach to come to a meaningful conclusion.
Not to jump to the topic of abiogenesis, I'd be happy to talk with you about that in the future as well.
I just gave this as an explanation, or I just gave this as an explanation why I think that inductive reasoning is not a fit and sound basis to come to reasonable conclusions in regards of biology and biochemistry, because we are dealing with very different and several problems at the same time.
So that was what I was going to respond to. I would say that it's difficult to have an inductive path or an inductive argument for the origins of something like histones and chromatin dynamics, but you could have an inductive argument or an inductive path if you are asking the question, is this necessary for gene expression, which was something that you alluded to earlier. It appears that it's not necessary for gene expression.
Okay, if you can back it up, I am fine with that. It can be eventually that gene expression can occur without that system in place. And of course, prokaryotes, they do not have histones and all this kind of stuff, and they do express their genes just fine. The question is, how do you go from a system where histones and the histone code and all this technology is not needed to a system where it is needed? And I think that is the jump which you have to make and ask, is a stepwise gradative evolutionary improvement possible? And that's why I say, well, what good is if you have a new reader protein which can read the histone code, but there is no histone code yet? That is the problem which I'm pointing out.
Yeah, so I jumped into the literature. Give me 1 second on Tangelo. We're just getting out of the car, getting settled at the house.
Yeah,
Give me
no
like
problem.
1 minute.
Yeah, feel free, no problem.
Hey,
Hey,
sorry about that. When I walked in and my phone jumped onto the Wi-Fi, it bugged out. StreamYard bugged out. So,
okay,
all right. So now I can actually communicate unfettered. So thank you for your patience.
no problem.
Responding to the last statement you said, and this kind of references our discussion in the comment section. The current model is that the histone proteins themselves evolved before the histone code, and we probably need to put this into some context. Do you mind pulling up an image of the nucleosome for anybody watching?
Okay,
Just like
yeah,
a
I have
Google.
an image in my library. I can do that, no problem. Just a
Yeah,
moment.
you do have some really nice artwork.
You want me to put from that page where I describe the histone modifications? There is also the
Yeah,
right
just something that
the histone. Yeah,
just
okay, I take
something that
another one. Just a moment. I have here another article, so I can put that one in.
and I've pulled up an article that's the title of the article is Chromatin Evolution: Key Innovations Underpinning Morphological Complexity. And I can read a little bit out of it. Its first figure, I think, is useful for this discussion. Okay, so so this image is a representation of what a nucleosome is. This is not what you would find in any living cell. The amino acids, basically, they're all of these images are going to be representations, and unless you pull up an actual electron micrograph, which you might be able to.
This is a nice picture, which gives a good idea what we're talking about, I think.
Yeah, these are. I've actually used that exact picture before for a presentation, the one you have there. So it does get to the gist that histones make up a core, a spool almost, that the DNA wraps around.
Yes.
So in this image that we're looking at right now, they've left out the histone tails.
Yes, yes.
So there is some evidence that the globular domains, so what's represented here in green as a green sphere, there is some evidence that those domains can be post-translationally modified. They can have functional groups added to them covalently that has all kinds of biological effects. However, that's not well established. It's not something that necessarily occurs under all circumstances. It's not as well established or characterized as the histone tails. So the histone tails are missing in this, and actually the fact that they're missing, this is kind of the point I wanted to make. Just the nature of the proteins themselves, that they are enriched in basic amino acids. Each histone of the core octamer is positively charged, and DNA is negatively charged. So you have one of the weakest, but still a significant ionic bond, an electrostatic interaction between the DNA and the histone. So if you think about it, the purpose, the role, the function these proteins play in a nucleus is they take a unique strand, the DNA strand that composes chromosomes is meters long and nanometers wide, and in fact, it's unique in that respect, and that's part of the reason it's of interest to material science. It's a molecule that exists in both the macro and nano scale, and I'm not aware of any other substance that that meets that same kind of criteria, that its length is in meters, but its width is in nanometers. So because it's very, very thin but long, you can coil it to make it take up less volume. And I know we've had other conversations with others in the past about chromatin condensation. But even without the histone tails, with the histones themselves, just the globular domain, the green sphere that we're looking at here, you have a negatively charged DNA sticking and wrapping around that positively charged protein. So to answer your question earlier, what function could it provide? And I'm paraphrasing your question, but what function could it provide without the histone code? Well, what you would get is a simpler, more primitive, more rudimentary form of condensation.
Okay, so let me ask you something.
Yeah.
Are there organisms which do not use which do not have a histone tail, where just the core exists?
I don't know off the top of my head. I don't know. I do. If you want to pull up this paper, the first figure shows kind of the distribution of histones among land plants, then unicellular organisms, archaea, and bacteria. And basically, histones are missing completely from bacteria. Archaea,
Yes.
some archaea have some histone-like proteins, most similar to histone H3 and histone H4. That if I were in a situation where I could, investigate this, that's where I would start. What the histones of archaea, do they contain histone tails? I don't know if you want to Google that, or my answer to that question is I don't know.
It would take time, but I can do that after our chat and have a look if there are organisms which do not use the histones with tails. I can check that afterwards.
Yeah, I found, just while you were talking, I found a 2018 paper, Structure and Function of Archaeal Histones. Let's see what their figures look like.
I can check histones without histone tail. Maybe that comes something up. Let me make a quick Google search here.
So at first pass, they don't appear to have histone tails. Let's see.
I don't see anything here. Maybe there is some paper which describes histones without histone tails, but right off the first search here, I don't find any paper which addresses that question.
So in this paper, again, the title is Structure and Function of Archaeal Histones. In the author summary, I'll just read it. We analyzed a wide variety of archaeal histones and found that most, but not all, histones possess residues able to facilitate hypernucleosome formation. Among these are histones with truncated termini or extended histone tails. So it seems like in this analysis from 2018, they found a spectrum of histones, some containing tails, some that did not have, they were truncated, meaning shortened.
Yes, shortened.
So
that doesn't mean that shortened tail eventually does not have any code information.
Oh, sure. Yeah. Well, even as I mentioned earlier, even the globular domain. So the tail is where the focus of the research has been. It's the research we have done has been focused on the tails. But there could be a histone code. There could be a code in the globular domain, the green sphere in the image, but that's just it's not something that we can definitively say at this time.
Okay.
Do you get my my assertion that even without tails, even without post-translational modifications, just because of the nature of these are very small proteins as well, relative to most of the proteins found in a human or mammalian cell. Histones are quite small proteins. Even without the tails, you can have coiling of the DNA around the histone core, the octamer, just because of the electrostatic interactions between the histones and the DNA. Does that make sense?
Yeah, I got now. You think about that. Let's suppose you have a chromosome and genome without these histone proteins. Okay, it's about 2 years that I have made a more in-depth study of these things, so I don't remember the details. So my understanding right now is just so very superficial. I would have to study it again to give more information about what I'm reading recently. But as a concept, think that there are chromosome strands which do not have these histones. So how do you come to that architecture of histone coiling? I mean, if you do not have the right amino acid sequence, you do not have that form of a protein, and even less, you need the right affinity to have the attraction of the DNA to the histones. And how do you think that could have occurred by trial and error?
So again, acknowledging that this is speculation, because
Yes, of course.
no one was there to observe it.
We are just talking about hypothetically how that could have occurred.
Yeah, I do think there's a reasonable explanation for it, and I'll kind of walk through it. So what we're starting with is a functional or a cell. It would be prokaryotic most likely, because we see in prokaryotic organisms today there are no histones. It would be an organism with a small genome, like bacteria, like we see today. Small genomes are less reliant on this coiling, supercoiling, this condensation, because they don't have to pack as much genetic material into as small of a space. Now, bacteria are much smaller than human cells, but even though they're much smaller and their nuclei are proportionally smaller, they still have a very small genome compared to ours. But they have a functional genome. It contains genes that produce proteins. So within any organism's genome, you have leaky transcription, meaning you have regions of the chromosome or regions of the genome that are expressed, i.e., DNA polymerase comes in, transcribes the gene, produces a messenger RNA, and usually those messenger RNA are shunted through, in human cells, they're shunted through the long non-coding RNA pathway, and it actually shuts that region down. So if you have the centromere or telomere, if they loosen up and begin to have transcription taking place, the transcripts or the mRNA that's produced by those regions actually form a kind of a targeting system for complexes to come in and condense that region back down so that it maintains its transcriptionally silent state. That's kind of a rabbit trail. But back to our hypothetical, we've got a bacteria and it's got leaky transcription. This is not controversial. So if you transcribe region X, you produce a protein that contains a high proportion of acidic amino acids. You transcribe region Y, you produce a protein, if it's translated, that's rich in basic amino acids. Basically, what the point I'm making is all it would take to get the essential function, the essential basic function of histones is for a bacteria to produce a basic protein, a positively charged protein. Once that happens, the DNA will, without any input through ATP, without any energy input, the DNA will stick to it. And so by stick, I mean, it would initially probably be one or two nucleotides forming an ionic bond with a few amino acids like glycine or arginine of this putative histone. And then because they are bound there, the neighboring nucleic acids are now much closer to the histone than they were before. So they form ionic bonds, and you spontaneously get the DNA to coil around it. Does that seem
Yeah.
reasonable to you?
Well, the problem which I see is that how do you get even close a protein which resembles a histone protein? I mean, you know that in a vast sequence space, to have a sequence which will fold into something in a 3D form, it is minimal, the possibility and the chance that that will occur by chance. So let's suppose even that that happens. Then you have even a smaller chance that you will have something that will resemble somehow a protein which will have sticking the DNA to it. But even if it does stick to it, that wouldn't occur in that nice form, in that coil form, which we see that situation here with H histones and the DNA nicely coiled around it. We would have eventually something that sticks at one or the other amino acid to the protein, but until you have something which is orchestrated like we see it in the histone core, there is, in my understanding, a long way to go until you reach that.
I'm not sure I'm following you. So you're saying if you grant that the bacteria begins to produce very small basic proteins and that these proteins are localized to the nucleus, there's no way that the DNA will coil around it in a sophisticated manner, like what or a specific manner? Are you saying that it would make a mess?
Let's say that it eventually would stick with one or the other amino acid to that protein. It would stick to it, but not in an organized fashion. It would be something in a chaotic manner rather than organized.
Yeah, so I can grant that, and even if the initial histone to DNA interactions were chaotic, they could have still provided an advantage, because one of the biggest benefits you get from histone packaging of DNA is that the DNA is protected from nicks and double-stranded breaks. So in this circumstance, that this hypothetical we're describing, even if it's initially chaotic, meaning, I think there's only so much chaos that is permissible in this three-dimensional environment, because we're talking about very small distances between the man. I wish I could draw this out on the screen for us to kind of look at together. So say you have this nascent histone protein, this histone-like bacterial protein, and it binds, one side of the histone binds to the DNA, but the other side, so thinking of it like a basketball and a rope, say instead of the rope binding coiled tightly around it, are you saying that you would have a loop in contact with the basketball and then maybe a 6-foot section, and then the other end would contact the basketball, so that you have not a neat, tightly coiled structure, but you would have effectively a sphere with like these coils hanging off of it in multiple directions. Is that what you're just getting at?
It would stick, first of all, it would stick chaotically to the protein. It would not be in an ordered fashion around the histones as we see it here. That would be the first thing. But secondly, as I said in the video, that the human genome has about 30 million histones where this is coiled. So let's suppose that you have by random mutations, you have some product which is an amino acid which has some sticky features. But I mean, if you just have one, and you need millions actually, or many to have something which is actually somehow organized. I mean, if there is maybe eventually one protein which was synthesized occasionally by mutations, which has no specific function in regards of joining or coiling DNA, it will stick maybe somehow because some of the amino acids have the ion charges which permit it to do it, but it will nonetheless be chaotic. And there is no organization to start the production in a series of histones which are all the same, and then a regular production through DNA replication, which then in the end will become what we see today. I see this is a very, very hypothetical hypothesis, which I don't know if that makes actually sense, if that would be a trajectory which would be possible.
Yeah, no, I acknowledge that we're certainly talking about this hypothetically, but I think the interesting thing about this hypothetical situation is that there are examples of what we're talking about in the literature. There are observations that can be made which support this hypothetical, and we can get into those as we go. But just to kind of finish this, chaotic coiling versus symmetrical coiling or specific coiling, I'm not sure what's way to define it. The point I was making initially is that even if it's chaotic, you could benefit from it.
There are exactly 147 base pairs of DNA that are wrapped around each nucleosome. So it is very precise, and to have this in a repetitive manner, that in my understanding is the problem. You have, let's suppose, a accidental genetic mutation which will produce you a protein which accidentally will fold into a 3D form, and the sequence is random. Now, eventually, you have some amino acids which will confer that attraction of the DNA, and it will stick to it. So you have this configuration. Now, from that, how do you start to make a series production of millions of histones, and then getting to that kind of orchestration and functional system which we see here? I don't see how. I mean, from an engineering standpoint,
the answer from that you would get to that question from the community, and I know you won't find this satisfying, but the answer that my peers would give would be natural selection. That the individual bacterium that first started producing these very small basic proteins, and I wouldn't grant that there's necessarily a single one. You pointed out that there's 30 million, in a human cell, but it's not directly analogous to a single bacterium. The genome size scale is just much different. You wouldn't need 30 million to package a bacterial genome. So if you have transcription of this gene producing, these histone-like proteins, maybe a few dozen or a few hundred dozen, it could, the way transcription occurs in a cell, you could rapidly transcribe, hundreds of these things in a very short period of time, depending on promoter dynamics, transcriptional regulation, all sorts of things.
I would
But if
see
that
another.
bacteria,
I would say.
let me finish this, and I promise. If that bacteria, even if it's chaotically packaging the DNA, but now that bacteria is more resistant to UV light, which is a ubiquitous source of double-stranded breaks, particularly in single-cell organisms like bacteria. In fact, in the lab, we routinely use UV lights to sterilize or decontaminate our cell culture hoods. If you even with chaotic packaging, if there is a fitness advantage, then it would perpetuate. And then that's I knew you wouldn't be satisfied with that answer, but that's what I would offer as the explanation, is that I'm sure initially it was chaotic packaging with just this, and we look at modern nucleosomes in mammalian cells, they're made of 8 core particles: histone H2, H3, H2A, H2B, H3, and H4. Histone H1 is a linker outside of the nucleosome. But presumably, and actually, as we're talking, I'm pulling up some papers. In some bacteria, there are histone-like proteins, and the description I'm seeing, they don't form octamer cores to form a nucleosome. You can have, I think it's reasonable to say, a single or even very few histone proteins bound together to create kind of a particle for the DNA to wrap around. Even if it's chaotic, the DNA that's wrapped up is protected more than the neighboring bacterium who's not expressing this histone-like protein. And then, so then you would have propagation of that particular bacterium because it Go ahead.
Yes, I wanted to interrupt you when I was going to say this. I have not the details right now, but we know that the unbinding or the loosening of the DNA around the histones, it is a very, very precisely orchestrated and fine-tuned process. And let's suppose that you have suddenly a protein to which a DNA strand sticks, and then there is, I don't know how it works in prokaryotes, but of course there is the gene regulatory program which orchestrates the precise expression of the genes in the right sequence, depending on the input also from signals from the outside to adapt to the environment and so forth. So this is all very, very precisely orchestrated. Now, let me suppose that you have a bacteria where suddenly such proteins are by mutations synthesized and they are floating around there, and some chromosomes, they stick to these particles, to these molecules. And then comes the machinery which has to recognize the section, the gene section, which has to be expressed at that time. And if there is no precise mechanism how to unbind or to loosen the forces around of the histone in order to have the RNA polymerase to have access to the gene section, well, what will happen? It will be a disaster.
Well, what you're talking about is competition between transcription factor binding, any kind of so histones are effectively DNA binding proteins. Other DNA binding proteins actually activate transcription. So if you have a discrete region of the DNA that's chaotically or semi-chaotically or non-chaotically bound by these histone-like proteins, you would have a competition between the binding of those histones and the binding of transcription factors. And what we see in all biological systems is that these interactions are at an equilibrium, meaning that they aren't maintained throughout the life of the cell, that everything's in motion, everything's changing. So effectively, the point you're making is a good point. The counter I would say to it, though, is that if a single bacterium produced histone proteins that outcompeted transcription factors and the RNA polymerase machine to transcribe genes, then that bacteria wouldn't have survived, because
exactly.
bacteria,
It would have destabilized the system, and I don't know how the machinery would have dealt with such a situation.
I mean, it effectively would have had to evolve histones that don't bind more tightly than can be dislodged by the transcriptional machinery. So again, selection could overcome that. It's a valid challenge, and it's a challenge for the cell. Packaging of one of the major functions of chromatin packaging in our cells today is to inhibit transcription. But the packaging that inhibits transcription isn't just the base nucleosome. So in human cells and lots of eukaryotic cells, even down to yeast, you have the nucleosome making up the basic functional unit. But then you have like 6 tiers of additional coiling and supercoiling to produce what's known as heterochromatin, which is the most densely packed form of DNA or form of chromatin that we know of.
And there are even more amazing things like the sperm, which uses protamine, which is the highest density of packaging of chromosomes, and it is like encapsulated like in a bullet, in order to be protected from the environment and be able to go to its journey to find the egg. And this is such a highly orchestrated procedure. I don't have the details now because it's some years that I studied it.
I don't think that description is inaccurate. It's way more sophisticated and complicated than we've described so far in this conversation in human cells. But we can actually see in living organisms today, we can see a gradation from genomes that contain no histone proteins at all to mammalian cells that contain not only histones, but there are other proteins involved in higher order condensation. It is extremely sophisticated when you get into things like boundary chromatin, so regions that mark the boundaries between transcriptionally permissible regions and then heterochromatic inhibitory regions. That's where the histone code comes into this. In eukaryotic cells, it's extremely well orchestrated, but that is a big jump from the hypothetical that we were discussing, earlier, and it's a big jump from other living organisms that we can actually observe today. So it doesn't mean that the initial processes required immediately that degree of sophistication.
Well, you don't really know that, and I think invoking natural selection at the molecular level is a bizarre thing to do. Natural selection just doesn't help the idea of abiogenesis. It's in fact contrary to the idea. Chemistry demonstrates to us that complex molecules, especially polymers, they don't just stick around. So the idea that one complex mechanism can evolve and that it's going to sit around and wait for another complex system to arise that will be able to utilize it or interact with it to produce some kind of biological function, I think is complete absurdity. Because, excuse me.
No, we can have a one-on-one.
Excuse me. Excuse
You
me.
just jump
Let me
into a
finish. Let me
conversation.
finish my thought.
You're just jumping into a
just-
conversation.
Well, I was invited into it. I was allowed into it. So
I'm gonna
by the
bow out
owner.
now. I
So-
apologize.
So let me finish.
If you wanted to have a conversation,
If you don't mind, I could finish a thought, and then you
it's
can,
fine.
you know,
You're
say
welcome.
whatever you like to say. But
Good talking to you, Altangelo. I'll see you in the comments.
Yes, Nephilim free. Let please molecular biology finish his thought, and then you're welcome to bring up your point. Is that fine? I mean, molecular biology has just left the stream, and I think that's not the purpose. We were talking, and I think it is not in my interest that he leaves now the conversation, because I would like to finish to listen to him. Okay.
oh, okay, but I mean, he's gone now. But the only
Yeah.
problem
So
with guys like him,
no, I would
Ortangelo,
like
is
to,
that
no, definitely free. I would like him to come in to finish his thought. Then I would like to respond to him, and then you are welcome to bring up your argument. Is that okay?
okay, that's fine. But when I was in here for 5 minutes and heard him make one different point after a different point after a different point after a different point, and at some point, you know, somebody's got to be able to say something else. The problem, Ortangelo, with guys like him who think they own creationists is they never stop talking. They don't want anybody who's a creationist talking, because then you're going to make a point that's a problem for him, and his whole story he's just been presenting for 20 minutes crumbles, and he doesn't like that.
It is my
That's the
way
problem.
to listen carefully to what they have to say.
I
That's
was
how
listening. I was listening carefully.
that's how a conversation goes. And
Well, I didn't know that I wasn't allowed to comment.
No. It's not that you are not allowed to comment. If I let you in, then you are free to comment. But I was listening carefully to what he was saying. I'm used to do it, even if it takes 10, 15, or 20 minutes. I don't care. But when he finishes, then I want to respond to him, and then you are welcome to join the conversation and bring up your point. So is that fine?
The only problem, I'll just say this and then I'll be quiet, okay? The guys like him will tie in one thought with another thought with another thought, and they'll never ever stop. That's the point.
Yeah, but I have
you
no
give him
problem
3
with,
minutes, he talks
yes,
13. That's the problem.
Definitely free. I have no problem with it, and that's how I said it. I am giving them opportunity to expose what they think, and we are listening. And it's not just I speak 2 minutes, he speaks 2 minutes. It's perfectly fine that he exposes a thought for 10, 15 minutes. I have no problem with it, and then I expect him to listen to my views as well. So that's how I'm setting it up here.
Okay.
Okay. Molecular alchemy, please come in back and we can finish our conversation. I'll give my answer, and then Nephilim free is fine to come to step in and make his point as well. So I'll wait here until you come back, and I will give you free microphone to make your point. Okay, let's go back. Can you continue, please?
Why don't you pick it back up? Because I'm not sure. I do like this figure you're showing here.
You can finish your thought, and then I will tell you what it is. I don't know if you know about what I'm demonstrating here.
Well, I had finished a thought when Neff jumped in, and I don't mind participating in an open panel.
Okay.
I'm not against that by its very idea, but I thought that you and I were having a great one-on-one, and I'm trying to connect with you on these topics. because you're not a lay person when it comes to these topics. You've taken the time to actually dig into the material. So I mean, we've just barely scratched the surface talking about the globular portion or the core portion of the histone. You know,
Okay, so
we can get.
let me just tell Nephilim 3. You hear molecular alchemy. It was actually at our beginning in our agreement to have a one-to-one conversation. And I apologize that I didn't make that clear to anyone which is listening to us, but I'm sorry for that. So I would prefer right now that this one-to-one conversation continues. And when we are finished, then I will let other people in and they can give you their comments to what they listened.
Cool.
Okay.
So just to kind of put a bow on the conversation to this point, we did venture into speculation, but you know, at the beginning of this conversation, we both acknowledged that we don't, short of having a time machine and a big enough time machine, you know, to take all the instrumentation of a molecular biology lab back 3.8 or 3 billion years ago and actually investigate this firsthand, we are left with speculation, except that we can test our speculation in a laboratory. So, and this was one of the things that you and I talked about a minute ago, just to kind of reiterate it. If we say something like the histones came before the histone code, I think there's a rational path, a rational justification to say that. But I'm not going to say that the histones did arise before the histone code. I mean, the histone code entirely depends upon the histone. So the options you can't have a histone code developing before the histone, but you can, and this is kind of what Tangelo, how you've described it. You can have them develop simultaneously, instantly. And if we had evidence for that, I would say that would be great evidence for creation, that it happened simultaneously.
Well, if you remember what I asked you right in the beginning, I said, what came first, the histone code, the histone writers, the histone readers, or the histone erasers? And that is my rationale and line of reasoning when it comes to basically all information systems which we see in life in the cell.
Say that list one more time for me. The very first word, the very first item on that list kind of broke up.
Basically, that the software and the hardware, one is dependent on the other, and one has no function without the other. And that is what I think we see here too. We have the histone code, which is the language written on the histone tail, and we have the readers, which can read and understand the message on the tail, and we have the writers, which actually read on the histone tail the message, the sequence of the amino acids, and then are the erasers. When the message has been read and used by the machines, then it can be erased, and the message can be rewritten with a different message. So we have here 4 components. We have actually the tail itself, we have the code, the sequence of the amino acids on the tail, which is meaningful. It is a code which instructs how to do things, how to express genes, when to bring the RNA polymerase machinery and so forth to the point to start this operation. Then we have the readers which read the information to take actions, and we have the writers which read on the tail like a pen on a piece of paper, and then we have the erasers which can erase the information sequence, and then writers can come there and write a new sequence. So my question was, what came first, the proteins which do these functions, or the code itself? Because if the code is not there and if the information is not there, then this machinery has nothing to do. How would it have evolved separately?
Yeah, I don't know. I would say so. So you've kind of phrased it a couple of ways. Initially, you asked if the histone tail came first. It was in part of your list. Then all the histone modifying enzymes, which is just another way to say writers, readers, and erasers. So the histone tail certainly came before the writers, readers, and erasers. And I think this would be a perfect opportunity to pull up one of those excellent graphics that you have of the histone tail. Is that something you can share on the screen?
Sure, no problem. Just a moment.
So while you're pulling that up, so my specialty is histone epigenetics. That's what I did my dissertation on. And we actually, our lab, my mentor actually, he did his postdoc under David Alice at Rockefeller, who is one of the fathers of the histone code. This is a big part of what we do.
Just let me shut up the cellular phone which is talking behind me. Just a minute, please.
In fact, I love this image because when I first got started in this, there was maybe 1/10 the amount known that's shown here. All these writers, erasers, and I think that's probably all you have. Yeah, just they're transferases, or they're either writers or erasers. So this is not even, well, I guess no, the bottom one is a methylation reader, the light blue. So that is included. So kind of talking about this basic concept again, so again, the histones themselves, the globular domain, so that means the spheres represented in this image, they're basic, so they have a net positive charge. They will bind to the DNA, and I know we've talked that to death. The histone tails are also positively charged, and the current model is that these histone tails are unique among proteins in a sense, because what you have is the primary structure of the protein that's floating freely in this water environment, and it's capable of floating freely. Let me put it that way. But what it also does is it actually lays down on the DNA strand, specifically within the minor groove. So within the DNA coil, there are both major and minor grooves. So the tail binds to the DNA strand at that point. So again, you have these ionic interactions between the positive charge of the histone tail and the negative charge of the DNA. And one of the most basic functions of PTMs, or post-translational modifications, these methyl groups, phosphorylation, acetylation, all these different groups, is they actually disrupt that histone tail DNA interaction. So if you have just a writer, such as a histone methyltransferase or a histone acetylase, a writer alone, adding a post-translational mark to the histone tail can disrupt the histone DNA interaction. So you can loosen the DNA simply by having a writer. That observation indicates that perhaps the writers came first. And you know, the part of this conversation that's missing is what has been studied in this respect, as far as the evolutionary history and the distribution among all life. And while I have studied histone epigenetics in depth, we are a cancer research group. And I know in your other video you mentioned how alterations in pathways like this can cause diseases That's absolutely something we see in cancer. But so again, the histone tail interacting, it kind of reaching like fingers on a fist, reaching around and grabbing the DNA by adding a group, a functional group like a methyl group or an acetyl group to the histone. I'm sorry, my 5-year-old is in here. Will you go out? Hold on a second.
Yeah, no problem.
In fact, you can summarize kind of this figure for everybody if you want. Give me 2 minutes.
Okay.
All right, I'm back. Sorry about that.
Yeah.
So do you follow what I know you follow it. You have a good understanding of this stuff. But does the way I described it, is that consistent with what you've read?
Yeah, I come back to my initial point, molecular alchemy, which is that let's suppose that you have even somehow a mutation which provides you such a histone tail. Okay, let's suppose you have already an evolved histone chromatin center and histones and everything, and you have the tail already there. Now, how do you go from there to that orchestration, which is very finely orchestrated, very precise, which involves all these hyper complex proteins, which, as we said previously, they read, they write, they erase, they communicate with each other, within each other, they communicate even on long distances. How could that have evolved in a stepwise evolutionary manner? This is what I put a big question mark on the hypothesis, on the evolutionary narrative.
And that specific question, I don't have an answer to it. And I do not come to the same conclusion as you, but I can see how somebody can look at this stuff and infer that it was created, it was designed for this purpose. You know, that's not a big problem for me. I'm not out to disprove creationism. And I mentioned to you in the comments, you know, a lot of my peers are devout, sincere Christians. Go out of here. Sorry, Mom. Go out of here, baby. Sorry.
No problem. Yes, but I would like to come back to my answer to you when you said, well, I would be interested to have a conversation, but I don't know if it's productive. And I answered you and I said, the evidence is what we both have. It is the same. There is no divergence. What is, and there is no question about it. Now, the thing that proponents of evolution and creationists disagree is the philosophy, is how do we best explain its origin? And of course, materialists, they will say, well, it's plausible, it is possible. We can suppose that it has an evolutionary trajectory of stepwise coming into existence of these high-tech machinery. And I, as a proponent of intelligent design, I see in these systems designed because, as I said previously, if you have a code, but you do not have a message, then it makes no sense to have a code. But if you have a message and you do not have the means to write down the message on the paper or whatever medium, then the code and the message cannot be transmitted. But if you have all this and you do not have an information transmission system, which is a way to encode the information, then to send it and then to decode it, then the information can eventually also not reach its end goal or the purpose of the information. And I listed in the beginning in my chat with Jungle Jargon 6 levels of things that have to be there in order for you to have an information system. I can enumerate it again if you want, but I see in all this irreducible complexity or integrated complexity, or it is a system which has to work together. That is the software, the information, and the hardware. That's the materialistic aspect, which is required in order to have that transmission of information.
So this if we want to talk about the kind of philosophical side of this and describing these as messages and information, we would really need to define our terms. Honestly, I'm less interested in discussing that at this time than necessarily the specifics of histone epigenetics. I can understand your point, and I agree with you. It does come down to kind of philosophical leanings, how we interpret this data. I mean, that's unavoidable. I do think stepwise evolution of this image that you have on the screen right now, I think that's plausible. And I think we can look in the literature. In fact, I pulled up a paper, and I mentioned it early on, that reviews exactly that, the stepwise evolution of chromatin from less complex, from simple, or even in the case of prokaryotes, bacteria, non-existent, to what we see in the most complex forms, which aren't always necessarily in humans. But in this case, certainly it's present in humans, but it's also present in single cell yeast that we use to make beer. This entire sophisticated gene regulatory system is found in yeast.
Yeah, what would be good evidence, for example, if someone would demonstrate that there is an organism which is in a transition state, which eventually has a histone core, which has a histone tail, eventually even a sequence of amino acids on the tail, which would be a code or something, but then it is completely lacking the machinery to read, write, and erase that information.
So let's stop at that point there. So earlier we speculated, which we're forced to do. You and I both acknowledge this. Short of a time machine, we're forced to speculate and look at extant organisms, which exist from the extremely simple to the extremely complex today, and come up with these explanations. But so having a histone core with tails, that's what I was getting at earlier. The tail actually binds to the DNA and helps the nucleosome more tightly retain that particular sequence of the DNA. So having a tail without having a histone writer, so like a methyltransferase that adds a methyl group to the tail, or histone acetyltransferase that adds a different functional group. Even before you get to those, simply having tails creates a more stable structure than a histone core without tails.
Okay.
So we've kind of looked at this stepwise, starting with a bacteria that has histone-like proteins that it's producing. Now we're talking about kind of a more complex system, but still independent of the writers, readers, and erasers.
Yeah, there is another point which I would like to make, which is that if there would be intermediate stages of evolution from a prokaryotic cell, which eventually is in a transition state to eukaryotic state cell, then why do we not observe these intermediate stages in nature?
Can you repeat that? Artangelo, I am really sorry. My youngest daughter is demanding attention, and I'm the only parent home at this point. I may have to call it short at this point, or put it short at this point.
We can continue another day. There is plenty of opportunities.
Just to kind of put a cherry on top, I would be happy to have another conversation with you. And I don't mind participating in open panels, and I've done that before on other channels. But I appreciate you accommodating me and continuing with the one-on-one, because I think it's a slow process, because you're demanding a degree of rigor in these explanations that's respectable. I think we can get there, and I have some papers that might kind of help us along the way, and I'll send you some links to them so that I'm not dumping anything on you. But I'd be willing to try and get back on here tomorrow if that works for your schedule.
Yeah, so I just want to repeat that I did upload that video which I made 2 years ago, and that topic rather in a provisional way. So I am not in the technical details, because it's some time that I studied this stuff, but it would be certainly fascinating to go deeper into the details, into the questions of all this stuff, and you will have plenty of time to bring up your hypothesis and your views, and we can discuss that. And I think I'm trying to set up here at my channel a medium where we can do that in a respectful manner without, I want to leave out any kind of gossip and personal attacks and that kind of stuff. And in the end, if we disagree, that's absolutely no problem. I think we are all in the right to hold our beliefs and our convictions. And I think these kind of conversations, they bring us forward, they incentivize us to investigate further, and that's where the learning process is. And this is what I appreciate. So you are very appreciated at my channel, and thank you for being here, and be welcome to come back.
Thank you. It's really been my pleasure, and no offense to Neff. It's not that I didn't want to talk to you. It was just jarring how abruptly the conversation seemed to derail. So I'd be happy to talk to Neff. Opportunity arises in the future. I've got no problem talking to him as well. But I've enjoyed talking with you, Angelo. Okay. I do appreciate the opportunity.
Okay, great, molecular alchemy. Have a good night, and see you next time.
Thank you. You too. Bye-bye.
Bye-bye. Okay. Are you there, Neff? Okay. Someone wants to come in? Or I will close. I'm already 1.5 hours in that stream, so if nobody comes in to have a continuation, then I will finish the chat here. So I'm waiting a minute. If someone wants to come in, you are free to come in. Otherwise, I will stop the stream. Okay, so nobody comes in, and I will stop the stream. Thank you very much, everybody, which has been listening to my chat with molecular alchemy. See you eventually tomorrow at 7:30 GMT /3 my time. I will have a chat with Godless Engineer at his channel. So when this is done,
Sorry
then
to
I
hear
will
you're shutting
probably.
it down. I would have liked to have talked if maybe somebody else would come in. But
Oh, we can continue. I was just saying that unless someone comes in, I would stop the stream. But if you want to have a chat, I have still time, so no problem. We can have another chat.
yeah. Well, I can appreciate that you were having an intense conversation with the guy. And I didn't mean to be disruptive. But I would like to make an observation. It's been my observation that guys who know a whole lot about the biochemistry of life, that they do believe that by digging as deeply as possible into the biochemistry, they're somehow making evolution seem more plausible. If they can talk about similarities in histones found in bacteria and how they're more complex, and this other more creature has a different type of histone, and that's phylogenetics at the molecular level, in their mind. And so they think that talking about the details of biochemistry somehow makes it seem like, oh wow, okay, I guess that could happen. But it just doesn't add any plausibility to it. In fact, I heard him say a couple of things that were, I would say, consider kind of absurd. One was that where he invoked natural selection in abiogenesis, which you cannot do, because molecules simply don't stick around. Complex molecules don't stick around in the environment waiting for others.
So I think he was talking about how an already living bacteria could have eventually produced a protein which would have had um, the some amino acid sequences which would have attracted DNA to stick to that protein, and then somehow that would have complexified to produce more of these proteins. And I pointed out that, in my understanding, that would be actually prohibiting the DNA polymerase to start its operation when it would be needed to do it, because the DNA strand would be sticking to that protein in an unorganized manner, and there would be no mechanism to loosening the DNA strand in order that the machinery would have access and start its process of transcription. And that would be certainly a way of error and disease and cell death.
Yes. Well, it's worse than that. Polymerase is a product of its own translation. I don't see a way for evolution to solve that. I mean, for even abiogenesis to solve it, it's a product of its own translation. The machinery translates proteins that comprise the polymerase machine itself. So it depends on the very proteins for the codes for which it translates. So it's that's a chicken and the egg problem for the evolutionist. But he said something else that I found bizarre, and especially coming from someone who knows so much about the biochemistry as he obviously does. He spoke of these proteins sticking around, hanging around in water, waiting around in water. For something more to evolve, for other proteins to evolve, so they would have something to interact with. But as a biochemist, he ought to know that water destroys, denatures proteins and breaks down polymers readily. So the idea of abiogenesis taking place in a watery environment is a complete no-go. Because if you and this is why organisms, they decay, they decompose really fast in water, as opposed to on land. If you dropped a dead rat into a lake, he'll fall apart way faster than if you dropped him on dry land, because the water causes the proteins and the collagens, the connective tissues, everything that's made of protein or carbohydrate, it just dissolves. Water is a solvent when it's in a liquid form. And so the idea of the evolution of proteins in a watery environment, or the idea of a protein sticking around in a watery environment, waiting for even a year, much less 10,000 years, for a corresponding protein to evolve that would allow it to have a function of some kind is an absolutely bizarre idea from a biochemical standpoint.
Well,
Just not
one
even
of the
believable in
one,
the wildest sense.
yes, the problem is that the polymerization of amino acids requires the removal of water, and
Yeah.
that is a big abiogenesis problem.
Yes,
But
it
the
is.
other problem issue is which they are all simply neglecting and ignoring and overlooking is the simple fact, and that Dr. Tour has emphasized that many times, and I have said it also to in my conversations about abiogenesis, that molecules, they decompose, they become asphalts, they do not complexify by any natural means, and that is simply that is one of the smackdown problems in regards of abiogenesis.
Yeah.
And second, of course, the fact that to have a minimal genome to make a functional living, first living, self-replicating
Hmm.
cell is huge. It's over 1 million. It's 1.3 million nucleotides in Pelagibacter ubique, which is one of the smallest bacteria. And that is the threshold that abiogenesis researchers have to meet. How do you get a genome with that size with the right sequence? And the odds are far, far beyond what is plausible and possible.
Yeah. I agree completely. I agree. To to me, you have your own way operating, and I have a different way. To me, the idea of allowing an evolutionist to talk endlessly about the details of microbiology is a no-go because they're just going to string one idea to another, and they're going to they overlook when they do that. They completely overlook all the alleged all the problems with evolution and with abiogenesis, and they attempt to make it. They think that they make evolution sound more plausible by discussing the details of biochemistry, but the if you look at things from a little higher level, then there's all these manner of problems with things, and they don't like to discuss a lot of these guys the actual problems. They just want to tell you their endless story about how this we can posit that this histone is because this one seems to be a more complex histone in this organism than in that bacteria. Therefore, the evolution of histones, happened, and so it sounds like a good storyboard. Makes for a good storyboard. But then, what is a histone? I mean, it's a very complex. It's proteins, and proteins don't just hang around waiting for other proteins, especially in a watery environment. So you could never get the protein. I mean, and then they're overlooking also the fact that protein is a product of complex specified information, which is algorithmic and linguistic, and you can't get abiogenesis to produce linguistics, algorithms, or information. It just can't happen. So you can shut an evolutionist down before he gives you a 30-minute storyboard by just pointing out that the very premise of his whole storyboard is a failure from the start. And
Yeah, my approach.
all the other stuff.
Yes, my approach is I like to listen. I like to listen to understand what these guys are saying, and I have been many times been accused that I do not listen to what they have to say, and that is just a baseless assertion, and that's simply not true. I like really to understand what they are saying, and then make precise, pertinent questions in regards of the scenario which they are drawing. And
Yeah, I understand. I don't have a problem with that, and that it's good to understand the fullness of their arguments. That's true.
but our goal is to reach them. Is to. I have been accused recently that because these guys they have learned the biochemistry language and they try to adopt it just to make their case, and their end goal is just to propose the Bible. And I say, hey, that's true. I mean, my goal has always been to reach out unbelievers for Christ, and I make absolutely no I have nothing to hide in that regard.
Well, you know, Tangelo, though, the thing is, the simple, clear arguments against evolution, they do the same thing. You could spend an hour and a half going through the very details of some biochemical process in a cell, and end the conversation. The guy goes away being without thinking that. I just want you to consider what I'm saying. I understand where you're coming from, and there's, I think, value in what you're doing. But I'm just saying, the guy is going to go away thinking that he's got a strong case, and you know, there's no reason for him to begin to doubt what he believes. But if they're hit with problems right up front that are they're just insurmountable problems for their ideas of evolution right up front, then you're going to have one of two reactions, I think. Not necessarily while you're talking to them, but one of two results when they're away and it's over with, the conversation's over and they're by themselves or something. One of two things is going to happen within them. They're either going to revolt and they're going to say, no, evolution's true because, you know, and the psyche of them is going to say, because that's what my worldview requires. It must be true. Or they're going to they're going to have the opposite. They're going to say, wait a minute. I don't know how to overcome that. It may be that this guy's telling the truth, that life was in fact designed, and may begin to doubt that their naturalism is the truth. But their end result is going to be the same. It's just a matter, to me, it's a matter of how long it takes to get there. And I like to cut it short. I like to go straight for the throat. That's my style, you know.
It's hilarious because a lot of them are unaware, and when you hit them with it, it blows their mind. Angelo, do you mind if I screen share something? I was watching James Tour video, "The Mysteries of the Origin of Life." There's just a small part in there because they're, you know, they like to think they have it figured out, but he's got a little short clip from Nature where he talks about.
Sure, go ahead.
Okay.
Yeah, I
appreciate
agree. They do, and they also, it makes it more easier for them to just dismiss all the problems with evolution if they think they can. The more detail they can think about, then the less they have to think about the bigger problems.
Well, the thing which I see is that there are some people that they have literally grew up with that kind of thinking, with evolutionary thinking, and they are holding to that for decades, and they are so ingrained in that thinking that it is very difficult that they change for something which is more adequate, which has more explanatory power.
I agree. Yes.
You know, and
it's hard for someone like you or me to really, I think, truly comprehend the mind of a godless mind, because we're not that way. And like you, I think that's a good observation, potentially. It's difficult for us to truly understand such a mind because we, now maybe for some people who grew up atheist and then because of one thing or another, they came around to the truth and began to see that, hey, I need to question what I'm believing. I'm hearing some pretty profound arguments from these creationists, Christian guys and stuff. But for those of us who were brought up believers and never had a problem with believing in God, it is difficult to understand the mind of a person who's been brought up in a godless environment and is godless in their thinking to this very day, because they've never had reason to doubt any of the things they've been taught in school aren't true. It's all verified by science. It's all so true, you know, and it's all just been pumped into their head, feeding them more and more and more, and they just don't doubt what it is they've been.
Yes, I think a very basic problem which I see, which they don't understand, is the range of possibility to invent new things by chance, by unguided random events. And that's why I think that abiogenesis is such a strong case for us, because the crutches of evolution, they cannot resort to it. I mean, there are some of those which even bring Darwinian evolution into abiogenesis. Right. But I mean, the literature, the scientific literature, it says very clearly, biological Darwinian evolution starts with DNA replication and with selection of the different varieties of alleles. Period. What did start before? You can call it chemical evolution, but there was no natural selection. So
Right.
if you start to think about, hey, how do you select amongst hundreds or even 500 different amino acids on a prebiotic earth, the 20 which are used in life? Just that argument alone kills abiogenesis and materialism.
That's true.
Finished.
That's
Just
right.
one argument, but they
Right.
simply ignore it. They simply cannot understand there was no selection process on prebiotic earth.
Right. That's a very good point. They really truly do believe that there is such thing as natural selection in chemistry that would lead to biological chemistry. And that's exactly right, Otangelo. They believe that natural selection works all the way down to the level of molecules and atoms. They really do. Yeah.
Yeah, I asked them, hey, stop, think 5 minutes and think it through. And do you know what they answered? Oh, that's an argument from incredulity. And when they say this, I think, hey, that is such a stupid counter argument.
It really is.
Because, I mean, hey, I am justified to be incredulous that there was a selection process when there was no goal for chemists, molecules and elements to sort out to a meaningful set of building blocks, which then far in the future would become life. I mean, why would chemistry, molecules, atoms, and so forth do that?
And on top of that, Otangelo, by the time that molecules could arrange themselves into something complex enough that you could imagine it has begun to become actual biochemistry, by that time, the laws of nature have long ago destroyed whatever it was that was evolving already. It's already gone.
That's what I said before. Let's suppose that there was eventually a set of the correct molecules just joined together in order to be ready to complexify. They would not complexify. They would devolve. They would be randomized. They would become asphalts.
That's right. The evolutionist believes in this mystical, though non-existent, natural selection at the molecular level. But not only that, they refuse to acknowledge that science has demonstrated that matter simply moves towards entropy.
Yes,
everywhere,
correct.
in all environments. It just naturally does. Molecules break down. And that is the trend that you have to fight against, going uphill for the abiogenesis. Evolutionists simply just blot that out of their mind. They may learn it in school, in high school, and even in college, but they just they dismiss it. They lock that knowledge away in a vault and pretend it doesn't exist. They just can't accept.
Well, they also pretend that or they don't pretend. They believe in their mind that somebody else has told them that it's figured out. Can I show? I'm going to share this real quick. I think I got it set up now. I apologize about that a minute ago. Let me hit play here. Can you hear that?
A big bag of garbage to
yes.
Okay.
Right. Next slide. So you say, well, that's a book from 2009. Well, let me show you the primary literature. 2018 in the journal Nature. This is our top journal. You want to see what Nature will publish in this area? None of us could get away with this, except Origin of Life researchers do. This guy is Nobel laureate Jack Szostak. Here's what he writes on how did life begin. Let's go through it. I'm interested in it. How did life begin? I mean, the guy's a Nobel Prize winner. He must know. The early atmosphere had no oxygen. It consisted mainly of nitrogen, carbon dioxide, with smaller amounts of hydrogen, water, and methane. Lightning, asteroid impacts, UV light from the sun acted on the atmosphere to generate hydrogen cyanide, a compound of hydrogen, carbon, and nitrogen. Raining into volcanic or crater lakes, the cyanide reacted with iron, brought up water circulating through rocks. The resulting iron cyanide compounds accumulated over time, building up into a concentration stew of reactive chemicals. Okay, cool. Where are we? Life, as we know it, requires RNA. Some scientists believe that RNA emerged directly from these reactive chemicals, nudged along by dynamic forces in the environment.
Uh-oh. Problem.
Nudged has no, you can't put nudged in any of our articles. No scientist knows what nudged means. They don't know. Nucleotides, the building blocks of RNA, eventually form, then join together to make strands of RNA. Some stages of the process are still not well understood.
That's
You think?
just plain pseudoscientific nonsense.
Yeah.
How do these things hook together? Show me the chemistry. It's not there. Once RNA was made, some strands of it become enclosed within tiny vesicles formed by spontaneous assembly of fatty acid lipids into membranes, creating the first protocells.
Bam. They just did it right
As
there.
the
Step
membranes
7.
incorporated more fatty acids, they grew and divided. At the same time, internal chemical reactions drove replication of encapsulated
There's a point here.
RNA.
Hang on a second.
That is nonsense. Next slide. Here is, next slide, the figure that
Right
he
here.
showed. This is the figure.
Yeah, I've seen
From
this.
nature. This is his
Oh,
figure.
you have? Okay.
Cyanide derivatives and simple sugars.
good.
Those are not sugars.
You were
He
talking
says
about
this is
carbohydrates a
oxygen,
minute
carbon,
ago.
nitrogen,
That's why.
phosphorus. That's
Right.
fictitious. I don't know any sugars that have that chemical composition. You don't know that. He's lying to you. That's not real. Is this HCN? I mean, there should be a carbon, a nitrogen, and a hydrogen if that's HCN. And I'm colorblind, but I can see that's not really HCN. I don't know what that is. Maybe that's phosphate. I can see that. That'd be phosphorus, oxygen. Maybe that's phosphate. Okay. And then all of a sudden,
It just goes to show,
you get
man,
an
what
RNA nucleotide.
that they don't have
But
it
the problem is
remotely
that's not a
figured out.
nucleotide.
But you'll hear them parrot it all
It's
the
the wrong
time.
structure. By far, that's the wrong structure.
You know,
He
we're
didn't
getting
even put the
closer.
right structure. At least he could have put the right
Yeah.
structure. He didn't even put the right structure. Well, what's acting upon this to make it do this? Well, heat from here,
Here's what's
UV
funny.
light from there. Poof. Nobody knows. That's in nature. That's not in an 8th grade textbook from 2018. People think I selectively choose these things from crazy places. No, this is Nature 2018. This is what confuses even professors. See this and they think, oh, yeah, people know. Nobody knows. This is a bunch of garbage. This is garbage. Next slide.
Oh, that's scathing.
All right, exquisite exactness is needed in
Yeah, I
synthetic
apologize for that.
protocols. This is one of
But you were talking about he was talking about, like, you know, you get so far and you get something, you have to start all over again. You know what I mean? To you know, like if you was to get lucky, let's say if they want to say it started on clay, but you know, you don't have that time because each time you have to start over. You know what I mean? They don't account for that. So it's impossible, man. And they just need to come out and admit it.
And the leaps they take, step 6, 7, and 8 were all massive leaps of there it is, you know. I mean, give me a break. James Stewart was right to point that out. Can you imagine how the scientist who published that paper is going to feel when he watches this? James Stewart call his work junk, garbage. And oh my goodness. Now he's got to walk into university with his briefcase Monday morning after this. And there's, 1,000 students in that university have seen James Stewart talk about this. And he goes in there whistling, do, returning back to work Monday. Hey, did you see James Stewart talking about, I'm running late. I'll see you. I got to keep going. Can you imagine, man? Oh my gosh.
It's embarrassing because I mean you'll hear it all the time, even in debates on like MDD. People will say, we don't have it figured out yet, but they're working on it. They're close, and they're making gain. No, they're not. I mean, let's just be honest. Like he even said in the video, maybe he's like, well, we're willing to spot you, even DNA and everything that you would need. But he said, maybe one day they will create it in a lab. But they're not nowhere close now, and they're using these kits. You know what I mean? And then they're, we've been over this before.
Oh yeah.
But
I've got to get going, guys. I get up really early.
I just joined because I seen you in the chat. I don't ever get a chance to see you through the week, Neff. So I wanted to say hi.
Well, I'm going to be having a live stream this weekend, I'm sure. So drop in if you can.
Okay.
Same for you, Angelo. Thanks for letting me come in, guys. Have a good evening, and God bless.
Thank
God
you
bless,
for
Neff.
being at my channel, Neff, and see you next time.
Okay.
See you, bye.
Bye-bye.
And and thank you for letting me come in here on Tangelo. I didn't. A lot of times you're going in the daytime when I'm working, so. It's nice to be able to finally get into one of your streams.
Yeah, you are in Australia, correct?
No, I'm in the United States.
Okay.
Yeah, but
yeah, I am in Brazil, so I don't think there is much time difference. Maybe
there's
1
not
or
a
2
big
hours
time
or so.
difference, but we're just a few hours off, and you're like when I work a lot in the daytime, I'm a lot more busier than I am in the evening. So I'm always listening to you, but I don't get a chance to come in and talk a lot. So I'm glad you run a little later tonight, which I appreciate. But
Yeah.
I was disappointed that LPP's Matt Dillahunty backed out of the debate with LPP, which he's
Well, I'm not surprised at all. I mean, almost every time when I called in his show, he did hang up on me very fast, you know.
yeah, I
And
saw the video of that.
so he was complaining after he had the debate with Jonathan Lachey, and Jonathan Lachey was after that had a chat with Braxton Hunter at his channel, and he said, well, because he only likes to talk to Christians which do not have such a very well and good understanding and unable to make good arguments, so he can knock them down easily. And then he replied to him and said, "No, no, no, that's not true. That's not true." But that is actually true, and that has been seen clearly in my interaction with him. I invited him several times to have a formal debate. He has always denied it, you know, and it is obvious why, because they have no case. That's the truth.
That's
They have no
well,
case.
and well, he's more philosophy, you know. So he would not want to go into debate with you. I was surprised that he even entertained the idea of going against John because you know, and maybe he wasn't 100% sure. I'm sure he knew a little bit who John was through Godless Engineer, but he may have started watching some of his videos. I think it's quite possible. Even the one with Godless Engineer, where John's first opening, he just destroyed him, and he knew that he's not going to let him just stay on philosophy, which John is also. It's not like some people are good at philosophy usually, and they're good. Then some people are good at the technical aspects of science are not so good at communicating it. John's very good at both. And then the topic was broad. It wasn't just the Christian God, so he wasn't going to be able to just sit there and revert back to prove the Bible or anything like that. And John was probably just going to get into the intelligent design, which is more logical, probable, and plausible. And I honestly think that he looked for a way out. And speaking of what you were talking about, like I seen where he kicked you off. He's tried to say that you were trying to overtalk him, but what he does is he'll just mute the caller so he can overtalk them. You know what I mean? So he does it all the time.
Yes, yes. It is his modus operandi. You see that molecular alchemy came in, and I just let him talk, and I want that my opponent or my the person which I talk him, that he can make his case, And these guys, they are simply using this tactic in order that the Christian becomes disconcentrated and confused, and then even afraid to say something which he will be soon interrupted again. And that is his modus operandi. He is a very good talker, but that's what he does. He just talks. But I mean, fair debates and considering what the other side is saying and them asking questions and so forth, that's not what they are doing.
Well, I think John's going to talk a little. He went live earlier. I think he's going to talk a little more about it here in a little bit. But one point of it was, and back and forth in their email, which he got upset because John, was wanting to do a GoFundMe page, because he was going to have to take time off of work, to prepare for the debate. You can't. Some people could have the time to do it in their spare time, and some people don't, and that's reasonable. I mean, it's not like Matt doesn't make money off Patreon and just get money off his debates. I'm sure he gets speaking fees, so that wasn't the problem. So the problem was he said he called him a charlatan. I mean, so it was an insult that basically was a tipping point for him to cancel the debate. Look at all the insults he's slung out over the years. So, I mean, that's just hypocritical. And I honestly don't think that's the reason. I think he just risk reward. You know what I mean? Nothing for him to really gain because John's, relatively doesn't have the subscribers that he does. So he just figures that if he gets him on a point or two, it's going to really help John out. And he don't want to. He's just not going to go there. So he chickened out.
Well, I say it very publicly. I am open anytime to debate Matt Dillahunty or any atheist. For instance, I am not afraid of any one of them, and yeah, that's it.
It's getting hard to find people to debate you guys here. You know it.
Yeah, tomorrow it will be fun with Godless Engineer.
Yeah, I'm looking forward to that.
And let's see what will come out of that conversation. But my point is not to try to humiliate them. I know that atheists, when they come into a debate with a theist, their tactic and their aim is to destroy the theist.
Yeah, to use their rhetoric to win. Yeah.
At least most of them have these kind of intentions. And that goes first, they try to knock you down in a scientific argument. When that is not possible, then they will suddenly lower to personal attacks and attacks under the belt line.
Yeah,
that is how it usually goes.
If they don't attack you, then they'll attack you through the Bible. And that's why I was kind of excited for this debate, because the topic was tentatively going to be just the existence of God, or does God exist, or something to that sort. So it wasn't necessarily going to be the Christian God, which it probably even easier to defend the Christian God, but that would keep Matt from using his wheelhouse of his stockpile of just he's got one right after another he can use for the Christian God.
Yeah, he makes this for 15 years, but the problem is that when I called him and started to talk about cells, then he said, "Oh, you are calling into an atheist show, and
exactly.
Why don't you talk to a biologist?" And
exactly.
Then I said to him, "Well, what is your? Why do you think that you are entailed to talk about these topics if you have no understanding of biology and origins in general?"
Let me help you. You were just going to maybe educate him, I mean, which would have been what logical probably would have done in a roundabout way at some point, I'm sure, in the debate, which is, you'd have to talk about the beginning of life, the origins of life, abiogenesis.
That is one point, but a very, very
it's a strong argument.
Yeah, but one very, very important point in the argument here, Chris, is this: that their very basic epistemological framework is wrong, is false, and they only try to knock down theist arguments and knock down the Bible and say why there is no evidence, why they don't believe, and so forth. But I pointed out in one of my calls, when I called him to the Atheist Experience, which he occasionally did not hang up because there was a bet that he would not hang up, otherwise he would lose $20. and I said to him, why do you not put both propositions on the weight? That is materialism on one side and theism on the other side, and then weight those two propositions one against each other. And I have done this before, but why don't you do it now? Why do you not use so much effort, if you are a true agnostic, to point out why materialistic propositions also do not make sense, to then in the end to say, that's why I'm agnostic and I don't believe either one proposition or the other. That's not what he's doing. When it comes up, he will defend evolution. He will say that science sticks to evolution. That's why it's true, and so forth. So he actually is he is not an agnostic. He is an atheist, which to which atheism is a religion. That's the truth. And he has absolutely no intention whatsoever to give honest, reasonable consideration to theist propositions, which I had several interactions with him. I sent emails to him, which I proved to him that abiogenesis is not possible, just based on the statistics of having a functional genome. He said, "Oh, now bring me some evidence," and that was after his debate with Braxton Hunter. At the timeline of this screen of this video, I wrote up this, and it's in my library. And when he said this, "Oh, now bring me some evidence," at that point, I knew this guy is not serious.
No, he's not. He's not serious about the evidence. And that's so ironic because when he debates, like when he debate Mike Winger or Latchkey, he's like, your claims aren't evidence. Of course, that's a claim in itself, but I mean, that's his go-to, his little shtick. You know what I mean? Because he keeps it in his little world where I can't prove it, or you can't prove it. Therefore, we don't know. And it's just like, well, wait a second here. We got other evidence. Let's go here and look at the beginning of life. We have DNA. It's inert. It's a code. We know it's a code. Well, we know it's a code. A lot of people won't accept it as a code, but it's not analogous to a code. It is a code, and we can show that. And then, and bam, there you go. From there, you have an argument. And he does not want to go down that road because he knows that rabbit hole is going to lead nowhere for him. And so
it's not good for him. Yes,
no.
But
he don't want his audience exposed to that either. You know what I mean?
But you know that his audience is so mentally blocked and blind as well. I say it always. He is a blind leading the blind because his audience also has no grasp about even basic logical thinking. I called him and I said, something cannot come from nothing. And then he said, well, you have to demonstrate that nothing cannot produce something. And then I said, no. And then he simply did hang up on me. And then the crowd went on me and said, well, you have to demonstrate that nothing can do something. And I said, no, I don't have to demonstrate it because nothing is by definition the absence of anything. But I mean, hey, I made an entire article on nothing. Because atheists, they cannot grasp.
You get a little feedback on Tangelo on your side, I believe.
I don't know why, because I'm not changing anything in my setup here.
It sounds like maybe speaker. Let me mute myself. Okay, you mute yourself and then let's see if it's on your.
Okay.
Yeah, it's on your end for sure.
I don't know what's happening. Whatever.
It's just a little bit of a humming noise, but I can still hear you. So
Okay.
maybe it'll fix itself in a minute. But no, I follow you totally. I mean, he's got a lot at stake as far as his audience, and it wouldn't be good for him that, he doesn't like to go outside of his comfort zone. And I think he realized that with John, he would have to go outside of that comfort zone, and he was looking for a way out, and he found it. I'm surprised that he had to really just was James, through MDD. I think that he took it, because maybe James offered it. Then he maybe realized who John was and looked into him and then decided, maybe I don't want to go down that way, that path.
Yeah. The same happened with me with Aaron Ra. He also refused to debate me, And these guys, these atheist guys that know me, they refuse to debate me. And I mean,
well, I could see why. I mean, you definitely put in the work and put in the time, and you know what you're talking about. And so it's when somebody like you can put the facts to somebody, it's hard to squirm out of it. And I sure would want to debate you if I was on the other side, to be honest with you. And I'm sure that's why they block you. Of course, now John's blocked on his Twitter, so he's blocked John. So, he just going to block anybody from that puts forth anything that's going to challenge his worldview. And that's just like you said, that's just silent. You're not interested in the truth. You're just interested in your version of it, your worldview.
You're interested in what you want to be true. That's the truth. But Matt did block me on the email. He did block me on Facebook. He did block me to call in at the show. I mean, last time when I called in at the line, he did hang up on me because my wife was making some noise, and I asked her to close the door, and then he took it as an opportunity to hang up on me, claiming that I had interrupted him.
Yeah.
So that's how it goes, you know. And I mean, hey, I mean, it's their problem, because at the end it's their eternity at stake, and it's not mine. We are doing just what Christ told us to do. So.
Well, the bad thing on me is we both know that you're never gonna change Matt's mind, and but it's just the audience. I would love for his audience to hear a little bit, you know, because they, you know, you watch his shows. I've watched a couple of them. They're hard for me to sit through very long, but you know, it's kind of the same shtick he does, and you know, and they're in a little echo chamber, and they follow him to his debates, and it's usually. It's always like a philosophical debate, and of course he's good at his rhetoric, and he's good at his craft, and they think he's just this some kind of authoritative figure on it that just knows more than me, and they're putting their faith in him. You know what I mean? He's basically like their apostle, and they're his disciples. And it's a church. It really is.
Yeah.
It's
Yes. There are people which are following him for decades, literally, and I've seen many of those which interact in the comment sections, which thank him and say, "Oh, thank you, Matt. Because of you, I've been able to leave religion, and now I'm an intellectually satisfied atheist." And then sometimes I repeat, "Well, it's blind leading the blind."
Yeah, it was the same thing. If you remember back about 10, 12 years ago with Richard Dawkins, I mean, they were jumping up in his debate, or his debates and lectures, and almost like they were in church, you know, praising him and shouting, and it's just it's sad, man.
Yeah, he is like Richard Dawkins has been actually like a messiah for the atheist crowd, but today
I'd hate to be him on Judgment Day. You imagine how many people he's led down the wrong path, especially when his book now. Well, both those books really, you know, it contains information that's been really, overturned. I mean, it's like the selfish gene.
If you lead the blind watchmaker and so forth. He is just a blind believer in the religion of evolution. That's the truth.
Because he'd have you, and I know it's an old book, but I mean, those people will still use it. But you know, he in the selfish gene, he wanted to try to like make it look like genes are in there battling it out for survival, and that's, you know, but genes don't, you know, they're not alive. They don't battle it out for survival. You know, they just, you know, they're doing what they're programmed to do, and that's the key word, programmed.
Yes, it's data. It's huge amounts of information.
Exactly.
Not on the level.
Why is it so hard for them to get that it's actual data, man? I mean, if you unraveled all the data in your DNA, I think it's like it would go to what they said, Pluto and back 8 times.
And I don't know if you watched my recent video, which I made on biophotons, which is communication literally by light in the cell, you know. And I mean that. Yes, it's I think it was yesterday or so that I uploaded the video. You can watch it, and that is just mind blowing what I'm describing there. I mean,
I'll watch it. I'm usually a day or two behind on your videos because I try to get those in the daytime. Usually with you when I'm working, I put it on the background, so I'll get to it.
I mean,
I always appreciate your work, though.
I mean, if you see that we are now in the breach of introducing 5G. Which is literally information systems by light, you know, and it's a huge advance of what we are doing now. And in molecular biology, you see that cells used it since they have been created. I mean, the light is used in the cell for communication. Now think about this. This is information interaction at light speed.
That's true. Mm-hmm.
You know, and this is the highest technology that we can even devise. And you think about the proposition that the 5G network would have been invented by chance. You know, that's the thing, you know, and I mean, that's what we see in cells. That
Oh yeah,
cells
information is traveling through right now in your body. I mean, for you to even to see things, for it to be, go through your retina and then to be translated to visual cortex, and then to get back to your brain to get an image. That is super fascinating. I'm sure you know a little about it. A lot probably more technical than I do, but I've watched a few videos on it. It's mind blowing how you're able to see images and the amount of how fast.
It is incredible that the brain uses literally quantum entanglement to transmit information. And that is basically that you have the transition of information at light speed.
Right.
And that is at the limit of what is physically possible. And we are just at the beginning of grasp this kind of technology. And the science is just now in the last 4 years, they have made the first experiment where they have actually empirically proven quantum entanglement in the brain. And I show that in the video. I post paper and everything. I underline where they provide the description of what they've done and the evidence and so forth. They have repeated it last year in 2019. So that it is a fact that in the brain, quantum entanglement occurs. Now, they need really high-tech technology in order to be able to investigate this and to detect this kind of what is going on in the brain. And think about that, we are just in the beginning to unravel how this works.
It's crazy, and then you think of maybe DNA computing. You know what I mean? That's something that's fascinating all in itself. And DNA computers are faster and smaller than any other computer I think that I've ever known that's been built. So,
while these evolutionary biologists are still back in claims of the 19th century, we as intelligent design theorists, we unravel and see this kind of highest technology. And for us, everything what we see fits in the sense that we can explain this kind of high-tech technology by a super high-end, a super intelligent creator, which is far beyond our understanding or comprehension, which has the ability not only to create life. I have an entire video on electromagnetic fine-tuning. You can look it up at my other channel, Intelligent Design Academy. And the degree of fine-tuning to have light is fantastic. It is enormous. And you go from there to the point that you see that light is used for communication in biology. That's fantastic.
Oh yeah, the teleological argument that goes down all the way to the cellular level. It's its strongest at the cellular level. Abiogenesis to me, that's it's obvious that the universe is fine tuned, but when you get down to talking about what we're talking about, you don't have a lot of room for error. Because if one little thing, as well as I do, if something's off and the protein's not folding the correct way, the cell dies. That's it.
Yeah.
You don't get another chance.
And protein folding is a huge problem because science science cannot predict how a protein folds when they know the amino acid sequence. They cannot predict how it folds. And you need to know how it has to fold in order to have function. And this alone is also an evolution or abiogenesis killer, because you need a minimal set of about 1,300 proteins, and each one of those is life essential. And if one is missing, you have no life. And I have mentioned this in previous streams. There are proteins like membrane channel proteins. They have an affinity for iron import. And there are some just 3-4 amino acids which have to be at the right position in order to be able to recognize iron on the surface of the membrane. and then import it. And if you do not import iron into the cell, you have no life, because iron is absolutely life essential. There are many proteins which use iron sulfur clusters as for the reaction of the protein, and so they are absolutely essential. And there are many life essential proteins which use iron sulfur centers and cofactors. So think about this, about that kind of irreducible complexity. If you do not have the right sequence of just a few amino acids of an import protein on a surface of the membrane, you have no life.
No, and then that's not even, we're not even getting to the part of the cell. You know what I mean? Because you have to have some kind of something for it to be stable in. You know.
Yeah.
But you know, the clay hypothesis is garbage, because you would have to have distillery on it. There would have, somehow the water would have had to be distilled. You know, it couldn't just been water that's water that would have been what on the earth, like they would have said, would have claimed that in the conditions it would have been under, life wouldn't be able to form.
No, these are all ideas which do not.
That's why they're trying to use the thermal vents, But James Tour in that same video I showed mentioned that, you, a lot of these reactions you need heat, and then a lot of reactions you need the opposite. So you have to, posit that some of this is taking place here, and then it gets moved over here, and then somehow it comes back to here. I mean, that's when when it goes beyond the point of being plausible,
Yeah, I described that in my video of RNA synthesis, why it's impossible. And in one of the experiments made by John Sutherland, in order to make RNA, it's a paper from 2017, he had to take the ingredients from different environments and different conditions and mix them together, and it had to be in the right order and so forth. So it was all guided. And of course, on the prebiotic earth, you have just one environment. And of course, that doesn't work. So I've seen so many times people saying, oh, no, RNA on prebiotic earth, that has been solved. No, it has not been solved.
And it has not, but that just shows they have not checked into it. And that's what the whole movement of intelligent design is to put forth to show that no, it has not been. And they'll just hide everything, though. You know what I mean? They'll hide it. Like the soft dinosaur tissue. I always try to bring that up. You were talking about iron in that, and the way that they try to say that iron could preserve that. I don't care. You would have to be crazy to believe that, because, to cross-link that, you know as well as I do, iron, to get inside to that osteocyte, it's not like it's full of blood in there anyways. You know what I mean?
For me, these 2 points, and I have said that several times, the soft tissue of dinosaurs, of the remains, and the fossils, and the finding of the remains of Noah's Ark at Mount Ararat, these 2 points, they are so strong in order to confirm the young Earth hypothesis and what the Bible says, that my trust in the Bible has advanced so much with this kind of evidence.
Oh yeah, just the fact that they have all the fossils that we have that are perfectly preserved. That's how you get a perfectly preserved fossil, is you have something catastrophic that buries them rapidly. It has to be done. I mean, we find the creatures that are in the death pose, and they've got in the process that they've found them eating other animals. You know what I mean? Yes. So that's just
all evidence of Noah's flood, of a sudden burial of all these creatures.
So they can believe what they want, but when they claim that you have no evidence, it's like that it hurts. They just hurts because they don't know what they're talking about.
Yeah, no, it doesn't hurt me because I know they don't know what they're talking about. I mean, I've encountered with derision in a very frequent manner from those that believe the earth is old. And I really don't care, I mean, I care about what I believe. And when I believe something, it is based on evidence. I investigate, and when I have a good reason to believe something, then I believe it. And I mean, I can be ridiculed as much as they want. I really don't care,
You know, I understand the atheists and what and they don't care. They'll deny it regardless because they don't want to believe. But then you have people like, and I'm not trying to discredit nobody, but like reasons to believe. If you look back, you know, they made the prediction that the Neanderthals, you know, were not human. You know what I mean? And then the DNA comes out and shows that they were interbreeding. So they have to believe that humans, you know, bred with animals and just, you know, their prediction failed. They're not willing to admit it. And then they went on the offensive and attacked Dr. Mark Armitage, who his work is solid, peer reviewed. You know, basically he was fired for his peer reviewed work and won his lawsuit. And, you know, they compared it, and I think Fuzz Ronda compared it, one of his books, to Ripley's Believe It or Not, like he was just trying to put something out there that was false and try to get you to believe it. And it's so far from the truth. He's giving you evidence. If you go in there and look at his work, his microscopy work, you'll see the Philopodia coming out of the osteocytes, and it's stretchy. You know, that should not be there. You know, I mean, maybe you don't have to agree that dinosaur. You know that you at least have to admit that some dinosaurs lived a lot longer than the current model of evolution posits. You know what I mean? You have to. If you don't, you're being dishonest. And so
Hey, Chris, I'm over almost 2.5 hours.
no problem, buddy. John is doing for anybody else in the chat. I think John's just now starting his open mic subscriber party. He's got 800 subscribers, so congratulations to him. And it's an honor to be in your chat on Tangelo and speak with you. And I'll be looking forward to your videos coming out, and I'll catch up on the ones I'm coming behind on.
I was amazed to make the study and find out about all these things, and watch it and then leave your comments.
Yeah, I will. Thank you for your work, though. It truly is a blessing to have, because I look forward to it. Thank you, and have a good evening, sir.